All right, so two events A and B are independent if the probability of A is equal to the probability of A given that B has already occurred. All right, so 56% of all American workers have a workplace retirement plan, 68% have health insurance, and 49% have both benefits. Draw a Venn diagram to represent the situation. So, all right, so I'm going to do health insurance, retirement plan, and then obviously the middle is both and the outside is neither. So always start with the middle. So 49% have both, so in the middle we're putting 0.49. So then we're going to subtract that value off of each of the other percents to find the rest. So 56% have a workplace retirement plan. So 56 or 0.56 minus 0.49 would be 0.07. And then for the health insurance and not retirement plan, that would be the 0.68 minus 0.49, which would be 0.19. So then how many have neither? Yep. Oh, well, that's question B. I don't even read the question and then I'm like, oh, that was the question. All right, if a worker is selected at random, what is the probability that he or she has health insurance if he has a retirement plan? So this is the probability that they have health insurance given that they have a retirement plan. So this is the probability of health insurance intersected with retirement plan. So that's going to be the overlap divided by the probability of a retirement plan. So that's 0.49, or well, actually, 49. No, wait. Hold on. I need to check something. So I always forget if you use the actual decimal or if you have to change it. Oh, wait. Okay, no, it is the decimals. 0.49 divided by 0.56. So it's the overlap divided by all of them that have a retirement plan, which is 56, not just the 0.07. So then this is equal to 0.875. Are having the two benefits mutually exclusive?
What does that mean?
So mutually exclusive was if there's overlap. No, like they can't be mutually exclusive if there's overlap. So basically, if there's ever anything in the middle of the two, they can't be mutually exclusive because there's an overlap.
So it's no.
Right. So no, there's overlap. 49% have both. are having health insurance and a retirement plan independent events. So we can do the probability of health insurance, so I'm using this formula up here, should be equal to the probability of health insurance given a retirement plan. And I'm using that because it's a value we've already found. We've already found this one, which is why I chose to do for health insurance. Just to save extra work, but you could do it either way. You could have done probability of a retirement plan is equal to the probability of a retirement plan given health insurance. So this value here was this 0.875. The probability of health insurance was 68% or 0.68. Since those are not equal, they're not independent.
The only part, because it's all straightforward, but it's like the only part that confuses me sometimes. It's like the Venn diagram.
Like in how to draw it or like what to put in it.
Yeah.
So basically, I always will start out with the overlap. If there is overlap, which in this section there should be.
That's what has both, right?
Yeah.
Okay.
So that the middle section is where both things are occurring. So you take that value and you subtract it from the given value for the other two things. So like we did to actually get health insurance, we did 0.68 minus the overlap was 0.49 to give us the 0.19 that actually goes in here. So if you didn't draw the Venn diagram, because some of the problems, like especially in the book, I don't think require you to draw the Venn diagram. You could, if it said like the probability of A or B, you could do the probability of A plus the probability of B minus this probability. But if you've already got the Venn diagram labeled correctly, you're just adding up these three values inside. But either way, you should get the same answer. So if you wanted to check it, that would be a way to check it. All right, let's see what's next. All right. Okay, the soccer team shirts have just arrived in a big box, and people are just starting to grab them, looking for the right size. The box contains 4 medium, 10 large, and 6 extra large shirts. You want a medium for you and one for your sister. Find the probability of each event described. So, and we're assuming without replacement, we're assuming like it's not getting thrown back in, that once you've taken it out, you're leaving it out until you pull the next one. So the probability that the first 2 you grab are the wrong size. So the probability of, let's see, you want a medium for you and one for your sister. So that means there's 2 of them that, hold on, let me back up. 4 shirts out of the 20 total are medium. So if it's the wrong size, it's all of them but those 4 that we're including. So it would be 16 out of 20 times, we didn't put it back in, another wrong size, there would be 15 out of 19 then. This patent, they're doing research papers. 9th grade research paper.
I heard. I think they're like it's like a mini version of like.
Y'all is brutal.
But it don't seem too hard.
As long as you stay on the pace that she tells you to do, you're fine. But people start to get lazy and like not use class time, and then it just ends up.
Yeah, like writing the paper is the easy part. It's just the research.
Yeah. Well, yeah. The paper itself isn't bad, except for she does grade really hard.
Yeah.
So. So, the next question then, the first medium shirt you find is the third one you check. So that means that the first two were wrong. So that's basically what we already did here. And then the third shirt is right. So that would be 4 out of however many are left, because there are only 4 mediums to begin with. So it would be 16 out of 20 times 15 out of 19 times 4 out of 18. And obviously you can use a calculator when you do it, but that ends up being 0.14. So the first 4 shirts you pick are all extra large. What do you think you could do for that one?
Alright, so 6 extra larges. So everything aside from that is 14 and 20.
Well, I'm saying I want all of them to be extra large.
Okay, so it would be 6 over 20.
So that's shirt number 1.
And then you multiply that by 5 of 19. And then 4 of 18. And then 3 of 17.
Yep. And that comes out to be 0.003. So then D, we see that at least 1. So that's going to tell us we want to try to probably look at the complement. Of the first 4 shirts you check is a medium. So we would want to do 1 minus the probability that none of the first 4 are medium. So that's going to end up being 1 minus, and then in parentheses, 16 over 20 times 15 over 20 times 14, or wait, sorry, over 19, times 14 over 18 times 13 over 17, which is 0.62. And so that is the probability that one of them, could be more than one of them, but at least one of them is a medium. All right, so this one's a little different. So now we're having to read the values off of a table. So the probabilities that an adult American man has high blood pressure and or high cholesterol are shown in the table. So what is the probability that a man has both conditions?
So it would be like they're like complements of each other.
Well, no, so this is just a value straight off the table. So if they have both, that means that they have high cholesterol and they have high blood pressure. So we're looking for the one that fits both. So that would be right here. So it would just be 0.11. A man has high blood pressure. So we're looking in the column of high blood pressure and just adding those two together. Yep, so 0.11 plus 0.16, which is 0.27. A man with high blood pressure has high cholesterol. Okay, so this is a little bit different. Okay, it's about wording.
A man with high blood pressure has high cholesterol. Oh. So, wait, hold on.
This one's going to require some work.
So you need a formula. Okay.
So it's a conditional probability. Because it's saying that a man has high blood pressure. Okay, so that's like that's already occurred. So we're looking for that they have high cholesterol given that they have high blood pressure. So I'm just using abbreviations because I don't want to write it all out. So the intersection of the two things is what goes on top, which we already said was 0.11, divided by the probability of high blood pressure.
0.27.
Yep. And when you divide that, it ends up being 0.41. So then what about the next one?
A man has high blood pressure if it's known that he has high cholesterol. So if is when it's like, if it's when it's multiplying, right?
Well, so this is the same type of question as C.
Let's see. So it'd be the probability of high blood pressure given that they have high cholesterol.
Mm-hmm. So probability of high blood pressure given high cholesterol.
That would be 0.27.
So remember, the top is the intersection of the two values.
Alright, so 0.11 over points.
That's the same thing. So the bottom is always whatever the second thing is. So the probability of high cholesterol. So you need the entire row of high cholesterol added together.
So 0.32.
Yep. And that happens to be 0.34. Let's see. All right, so suppose the probability that a U.S. resident has traveled to Canada is 0.18, to Mexico is 0.09, and to both countries is 0.04. What? No, they want to know who's traveled to Canada but not Mexico then. Wait, what? I don't know what that last line's supposed to mean. We'll ignore that. All right, so what's the probability that an American chosen at random has traveled to Canada but not Mexico? Oh, that's not even supposed to be there. That's literally supposed to be down here. So I would probably try to draw the Venn diagram somewhere. I don't even know where I'm going to put it. I'll just try to draw it up here, I guess. All right, so I have Canada, Mexico. So how many have gone to both?
0.04.
So that's going in the middle. So how many have gone to Mexico but not Canada?
0.05.
And then how many then have gone to Canada but not Mexico?
0.14.
Yep. So then that value is just 0.14. What's the probability that an American chosen at random has traveled to either Canada or Mexico?
Um,
How are you getting that?
I just added the two.
So you also have to add the middle if you're going to add them like that.
Okay.
So, or can be both, or it can just be one or the other. So, or is every single category. If it said have traveled to both, then it would just be the middle. So, or would be all of them. So, 0.14 plus 0.04 plus 0.05, which is 0.23. Let's see. What's the probability that an American chosen at random has not traveled to either country?
It's his mother that's gonna do it.
Saturday? Okay.
He's been in to see me,
Okay.
and I have her all written down. We have to retype it.
Oh, I need to give you the other one. I need to get Miss Hughes to actually text it to me. She got sidetracked, I think, in the office.
Yeah, it's been a zoo everywhere.
Yeah. Okay. I'll text her after I'm done here. We're doing stats.
Oh. That number, when it's B, letter B, looks, I mean, that makes, that common sense. The math part.
Well,
How
yeah,
did you
point
get
one
the
four.
0.4 plus
Oh,
0.05
okay.
plus
I thought she meant she knew exactly where the question came from, and
No,
I was
I
sitting
don't
there
have any
cracking
idea,
up.
but I see up there in the little circles. Canada, Mexico, and you want to find out what that.
Mhm.
Yeah, no, I don't like probabilities either.
Oh, I love it.
That's, my Sarah did too. She liked stat. She doesn't like geometry.
I don't either. Oh, I that's a lie. I like geometry, but I would not like teaching it. Like, not in the slightest. But it's fine. Okay. I thought she just got it off the top. I was like,
Well, I thought she like had the whole question answered off the top of her head.
I was like, what? And then I was like, oh, you just mean the addition. Well, I hope that's common sense to anybody after 5th grade. All right. What's the probability that an American chosen at random has not traveled to either country?
So wouldn't it be the same thing?
So they've not traveled. The other one is that they have traveled.
I would just guess and say that you subtracted values
From what?
from each other.
So where in our Venn diagram do we usually put the stuff that's not?
0.77.
Yeah.
See, you ain't put that down, so I was like,
Because I knew it was a question.
cause like I didn't know it was.
What's the probability that someone who has traveled to Mexico has visited Canada too? So how would I set this one up?
As travel to Mexico, travel to Canada. That's what it means. Do you add them to each other?
So the probability that they have gone to Canada given that they have already traveled to Mexico. So what kind of probability is that?
That's the. I forgot what it's called.
conditional. So the probability that they've gone to Canada, given that they've gone to Mexico. So what would the numbers be that go there?
0.05. I mean, yeah, 0.14 over
So the top value is what value?
the top.
Think about the formula.
Oh, it's the one that's given, right? I'm so low.
It's the probability of Canada intersected with Mexico. So it's the probability of both divided by the probability of the second one.
Alright, so it'd be points 1, 9. Oh my.
The overlap. Top is the overlap.
That's
So top's always the middle.
0.04.
Divided by the probability of Mexico.
1.05. Are you
The
serious?
entire probability of Mexico.
It's our problem. Oh, 0.09.
Yes. And that comes out to be 0.44. This is definitely a chapter of knowing formulas. Are traveling to Wow.
It's time already.
I guess. Are those disjoint events?
No.
Okay, why not? Because some people have been to both countries. So there was overlap. Okay, well, we'll finish that tomorrow.